Okay, ready? Okay. Well, hello everyone. Welcome to the Unique Networks presentation. Today we're going to talk about the challenges the ecosystem should solve to bring the cross-chain NFT interoperability to life. Also, I'll share the Unique Networks vision of how this could look. But before we start, I want to remind you what NFTs are. It is known that non-fungible tokens are on-chain assets that represent unique objects. And often this is the end of the story. Yet I want to tell you that NFTs are more than that. They can have associated data, often called NFT attributes or properties. This related data is usually organized as key value pairs. You can see an example on the slide, an NFT that represents a character in an MMO game with name and class attributes. NFT attributes can be implemented differently by NFT engines, and the associated logic could be pretty complex. Let's see what NFT engines we have in the Polkadot ecosystem. There is the unique network parachain, palette NFTs developed by Parity, open runtime modules library NFTs palette, solutions based on smart contracts, and custom palettes. Some of them provides mechanisms only to bind immutable data to an NFT on creation. Others also allow users to modify NFT metadata. Also, it is possible to set up different access control systems, so only authorized accounts can modify NFT metadata. Notably, such a system can allow smart contracts to interact with an NFT and put some data into it, making an NFT an on-chain shared variable with given fields, similar to an instance of a class in a programming language. So when an NFT engine provides such metadata modification mechanisms, NFTs become more than just assets. They become a convenient tool for building on-chain logic where unique objects can participate in various engagements. Let's look at our MMO character again. Notice that I added the new attribute indicating the current character's level. Obviously, an arbitrary account should not be allowed to change this attribute. Even the NFT owner should not be allowed to do that. Because it is the whole point of a MMO game to make progress and increasing your character's level by making progress by achieving some in-game goals. So only this game smart contract should be able to change the level attribute. It will increase the character's level when some in-game conditions are met. Also, it would be lovely to be able to change the character's name. The access control system of an NFT engine could provide such permission to the NFT owner, say, Alice. And now she can set her character's name correspondingly. Now the interesting part. Remember I told you that an NFT is an on-chain shared variable, and because of that, it can participate in various engagements. Currently, we see only one engagement, namely the corresponding MMO game. However, there could be another. For instance, Community 42, which the corresponding smart contract represents. Let's say this community provides benefits only for those who possess a character of a precisely 42nd level. So when users interact with this smart contract, wanting exclusive benefits, they must provide an NFT corresponding to a character. The Community 42 smart contract will check if the user actually owns the given NFT, read the corresponding attribute, and check that its value is 42. So this was only one of the examples of what NFTs are capable of. With this in mind, I want to move on to cross-chain interactions and how NFTs can become a part of them. Let's see what parachains can currently do with assets using Axia. We can transfer assets using the resource-based transfer teleports. We can remotely lock and unlock assets. We can report the contents of the holding register, and we can claim assets. Technically, all of these operations can be applied to NFTs since they all work with the multi-asset type. And the multi-asset type can equally represent both fungibles and non-fungibles via the fungibility field. However, no parachain pair currently does that, because there are several unresolved questions. Mainly, there are uncertainties about NFT metadata, NFT attributes. And this is the crucial part, since the NFT metadata is the thing that determines the NFT value. Because of that, it is tempting to assume that we transfer an NFT asset, we must also somehow transfer its metadata. We need to do that, yes, but only when we are talking about teleporting an NFT. The necessity of transferring the metadata arises in the case of teleports because the NFT ceases to exist on the sender chain, as its metadata does, and will be created on the target chain. The NFT should be minted on the target chain in the same form as it existed on the sender chain before teleporting. So in this case, we transfer NFT metadata because we have to preserve the NFT value by keeping its metadata on the target chain. Otherwise, we'll lose the metadata and the NFT will lose its value. Okay, and what about the reserve-based transfers? In this case, we won't lose metadata when transferring an NFT because we don't transfer the object, we don't transfer the object itself when we use the reserve-based transfers. Instead, we transfer the ownership from one account to another. For example, Alice controls an account on the reserve chain. And currently, this account owns an NFT on the reserve chain. Suppose Alice initiates the reserve-based transfer of this NFT to the target chain. So the reserve chain transfers the NFT from Alice's account to the target chain's sovereign account, which the target chain controls. Then, the reserve chain notifies the target chain that the reserve asset was deposited. So the target chain can now mint a derivative NFT corresponding to the original one on the reserve chain. Thus, the reserve chain guarantees that the value of the NFT is preserved, hence we don't need to transfer metadata. You can think of it like that. The real NFT located on the reserve chain is a variable, and the derivative NFT located on the target chain is a pointer to this variable. Okay, but why transfer NFT then? The metadata is located on the originating chain and hence unavailable to the target chain entities such as smart contracts. Will the NFT derivative be useful? The answer is yes, it will, because even though the metadata is located on the reserve chain, we could add new XM instructions to make the metadata available to the target chain. Moreover, the new XM instructions enable new use cases for cross-chain NFT interoperability beyond transferring. Let me introduce these new instructions by showing examples of the new use cases they enable. Consider palette NFTs developed by Parity. NFTs created using this palette can have several attributes. Different actors, such as the NFT owner or the collection owner, can set their attributes. Each actor can set their attributes in the corresponding namespace, one for the collection owner and another for the NFT owner, so they don't interfere with each other. But also, the NFT owner can approve other accounts to set their attributes on this NFT. These approved accounts will have their corresponding namespaces for their attributes. This is what the palette NFTs can do. Now consider the following use case. For instance, the NFT owner can approve several smart contracts for setting new attributes. Each of these approved contracts represents some engagement in which this NFT participates. This way, the owner of the NFT can accumulate benefits from participating in various engagements, since they all will add new data to this NFT and hence will increase the NFT's subjective value. Yet, these interactions are limited by the scope of the chain where the particular instance of the palette NFTs is located. In this case, we are limited by chain A. Other chains could also provide engagements in which the NFT owner could want to participate, but they are not accessible. Luckily, we can fix this. We can introduce new XM instructions. I will use hypothetical temporal names. The main thing here is not their names, but their functionality. So the first instruction is approve metadata modification, an instruction for approving a given multi-location to modify the given multi-assets metadata. The second one is metadata modification approved, an instruction for notifying the multi-location that it now has permission to modify the metadata of the given multi-asset. And the third one is modify metadata, an instruction for making a request for modifying the multi-assets metadata values under specified keys. Let's see how the new instructions can be used. Say we mint an NFT on chain A using palette NFTs. Then we want to approve a smart contract on chain B for modifying the attributes of our NFT. We need to execute the approve metadata modification XCM instruction, specifying that we want to approve a particular smart contract on chain B for modifying the attributes of our NFT. This instruction should be submitted for execution by the NFT owner to chain A. During the execution of this instruction, the XCVM of chain A will send the metadata modification approved message, telling chain B that it is now allowed to send metadata modifications for our NFT. Also, this message tells chain B what specific interior entity should initiate such requests. In this case, only the approved smart contracts should be able to initiate them. Now, chain B knows about this permission. Therefore, it can safely send the modify metadata instruction. Chain B does that on behalf of the approved smart contract using the decent origin instruction. Chain B specifies the NFT for modification and the key value pairs. Chain A, during the execution of the modify metadata instruction, will verify that the XAM message origin was approved by the NFT owner. This way, we can allow NFTs to participate in engagements outside their native chains, expanding the NFT's applicability and interoperability in the ecosystem and beyond. Also here, these instructions were baked by mechanisms provided by Palette NFTs, which is developed by Parity. Other Palette vendors can also provide their means of metadata operations. For example, Unique Network can also support new metadata operations out of the box. Okay, sounds great, but you might ask again, why transfer an NFT? Why transfer NFTs to another chain when they can participate in other chains' engagements without being transferred there? To answer this question, we must remember that the reserve-based transfers are about transferring ownership rights, not the object itself. The ownership rights give you not only the opportunity to transfer an NFT further, but also to do privileged operations on NFTs, such as metadata modification approvals. Consider another use case. Let's say we have a parachain X, where we can create NFTs. For instance, Alice owns one there. Also, chain X allows the owner of an NFT to modify the attributes, but no approval mechanism is implemented on this chain. So on chain X, only the NFT owner can modify attributes. Imagine that Alice wants to leverage the approval mechanism nonetheless. She can transfer the NFT using the reserve-based transfer to chain A, where we have Palette NFTs that provide the needed logic. Since it is a reserve-based transfer, the sovereign account of chain A is now the owner of the NFT on chain X. Hence, the sovereign account has the right to change all the attributes. Now, Alice can leverage the approval mechanism provided by chain A. She can now approve several accounts for metadata modification. When an account tries to modify the NFT metadata, chain A will verify that this account is approved, and if so, will send the modification request to the originating chain. One note, in this example, the Palette NFTs provides the approval logic, but it could be another palette with similar capabilities. So by transferring an NFT, we obtained a facade logic for the NFT located on chain X. And that's one of the possible reasons to transfer NFT assets, even when we have these additional metadata-related XCM instructions. Also, the reserve-based transfers might not imply metadata interaction at all. For instance, the owner of the NFT on the originating chain might want to transfer the NFT to a Unique Network to fractionalize it, or to nest an NFT to a bundle of NFTs. In these cases, no metadata interpretation is needed. So the thing is, NFT transfers and metadata operations are independent of each other, and we can implement them separately. Moreover, there are no technical limitations to implementing NFT transfers right now. Because of this, I'm happy to say that our and Akala teams plan to create a proof of concept and make the first NFT cross-chain transfer in the ecosystem. But there is a caveat. To transfer a multi-asset between chains, we execute XCM programs on both the sender and the target chains. To execute a program on the target chain, we must pay for the execution. We do that using the by execution instruction. The caveat is that we have to know somehow in what currency we can pay. And currently we cannot estimate the fees we have to pay to ensure our program will be executed. It is an issue for NFT transfers because if we send not enough fungibles alongside our NFT, all our assets will be trapped, including our NFT, which could be subjectively very valuable for us. The Pallet XCM provides a mechanism to claim the trapped assets. However, it is hard to do since it implies appealing to the sender chain's governance. This problem will be mitigated by the new asset asset claimer instruction accepted to be included in the XCM version 4, but it is only a mitigation tool. Lack of fee estimation will also complicate any other XCM instructions, including the usage of the metadata operations presented here, since the user is again forced to guess fees, making the entire process fragile. Yet, the target chain knows how to weigh an XCM program, and it knows how to convert the weight into a suitable currency in which we can pay the execution. We need a mechanism to ask the target chain about currencies in which we can pay, and then we can ask it about the cost of an individual XCM program in the selected currency. The easiest way to implement such a mechanism is to make a standard RPC for querying the cost of an XCM program in the selected currency. Such an RPC will be similar to the existing transaction payment API for extrinsics. Having this RPC will enable the ecosystem to create front-end libraries for building convenient user interfaces and providing better user experience when using XCM, which is the most crucial aspect of adoption. We at Unique Network think that the ecosystem needs first to create such an RPC and the reference XCM JavaScript library for UI and wallet builders, even before adding new metadata instructions to XCM. We need to ensure the convenience of the NFT cross-chain interactions. And we can start with the basic interaction, namely with the NFT transfers, since XCM already can do that. The library will query the suitable currencies in which the user can pay for the execution. And when the user selects one of these, we'll query the actual cost of the XCM program. This way, the user doesn't have to guess the fees, and they can be more confident that the cross-chain operation will succeed. Also, this library must cover the case when the XCM operation didn't succeed, since XCM is a language of intentions and doesn't guarantee proper execution. To cover this case, the library should provide a convenient API for claiming all the trapped assets. After providing a convenient infrastructure for XCM transfers, we can then expand the functionality further by adding metadata operations. So here's the plan. The plan to bring NFT cross-chain interactions to life. First, implement the proof of concept of NFT reserve-based transfers. Second, implement an RPC for querying same information, which will tell us what currencies are acceptable for paying for the execution and how much the given XCM program costs in the selected currency. Third, implement an XCM JavaScript library providing a convenient API for using XCM. This library will construct the correct XCM program for the user and calculate the overall fees that must be paid on both chains. And finally, introduce the metadata operations, extending the infrastructure established in the first 3 steps. Oh, that's it. However, I have to mention that there are other questions. For instance, about the foreign NFT collection registration on different parachains. Also, it is unclear how we should manage these foreign collections. Yet, it is a more technical issue, and it doesn't seem to be very difficult. Also, it appears to have several valid approaches, so it is a subject for discussion and possibly different implementations. Maybe there are some other debatable things that we can discuss during the conference, but for now, that's it. That's all I wanted to show you today. Thank you.
Stay on the stage, please.
Okay.
Is there any question related to these unique NFTs? Oh, yes, there is. 1 minute, 1 sec. Here you go.
So maybe you have an idea, like while we're migrating to Polkadot 2.0, like I know it's still like in the process, but what is the future of XCM and specifically like XCM assets like NFTs? So, or if it's still like unclear, maybe you have some ideas how it might work with the new architecture.
I heard that core time should be sold as NFTs. Like, and Robert told us today that we can use different shares of the core. You know, we now using the whole core, and when we use just a part of it. Maybe the core time, the NFTs that corresponds to a core time can have an attribute about which percent of the core you are buying. Maybe this could be a use case. I will discuss this with Robert today.
Is there any other question? Okay. Thank you, Daniel.
Okay,
It was an awesome presentation. I really liked it.